All right, so here was mine. We're going to go look at these relationships up on what I've got on the board, but I also want to hear some feedback from you guys. So the lines that it showed you that were the horizontal and the vertical lines, the horizontal one, that is your Y mean. And the vertical one was your X mean. So Y bar and X bar. And I had gotten my correlation to be, I think, about 0.55. I'll go back and look at this here in just a second. So yeah, I got mine to be about 0.55. Part A wanted you to add a new point where? Over here on this horizontal line, way over here. So if I look at this as my y-axis, if I look at the edge as my y-axis, and I look at the bottom as my x-axis, this right here is the average of all the y values for those dots. That's what that y bar means. So they took all the y parts of these ordered pairs, they added them together. Since I have 10 points, they divided by 10. That's what this line is showing right here. This vertical line is the average for all the x parts of these ordered pairs. So if I add a point way out here on that y mean line, what happened to the slope of my line? It decreased pretty severely, right? So that decreased. What happened to the y-intercept? Y-intercept stayed the same, did it? Look at where it's hitting over on the left edge. When I put that point back over here, what happened to it? It moved up, it increased, right? Because it tipped my whole line. My slope went down, which pulled the back end up like a teeter-totter. So my y-intercept actually increased. What happened to my overall correlation? It decreased. All right, so when we add a point way out on the y mean line, the slope decreased, the y-intercept increased, and the correlation decreased. And that's when I added a point way out here. So that's for part A. All right, I took that guy away. Part B, we were supposed to add a point where? To the far left on the horizontal, so over here. What happened? Slope decreased. Y-intercept decreased. Or increased or decreased? Increased. My y-intercept increased. Oh, come on, go away. No, don't add more. Go away. Okay. There's my line right there. I have 11 points on here. How do I have 11 points? I don't even know. When I add a point way out here, notice my line shifts upward. I don't know where it's getting that 11th point from. All right, so let's go back and look. Here, I'm going to add that to my picture. When I add a point way over here for part B, what happened to the overall slope? Decreased. Y-intercept? Increased. My overall correlation? Decreased. These guys right here all tilted the line. My least squares regression line. All right, so now let's go look at what C and D to this. So we want to add a point below the least squares regression line on the vertical mean X line. Hold on, this is bothering me that I don't have a correlation closer to 0.5. All right, I added more points, but now my correlation is back to about 0.5. So if I add a point below down here, what did that do? It decreased my y-intercept. Did it change my slope at all? Slope stayed the same. My y-intercept just dropped, right? Take that away here. So when I add a point down here, slope stayed the same. My y-intercept decreased. We didn't check out what happened to the correlation, so I'm going to do this again. My correlation now is 0.5538. What happened to my correlation? Correlation decreased. All right, and then the last thing that we were supposed to do was add a point that was above the least squares regression line on the vertical line for the mean of X. So up here. What happens when I add that line? What happens to my slope when I add this line up here? Stays the same. What happens to the y-intercept? It's increasing. It's like popping my line up, right? What happened to the overall correlation? It decreased. All right, so when I add a point way up here, walk me through that one more time. What happened to the slope? Stays the same. What happened to the y-intercept? My y-intercept increased. What happened to my correlation? Decreased. When we added points to the y-mean line, it tilted it. What happened when we added stuff to the x-mean line? Did it tilt it at all? What happened to it? Shifted it up and down. What happened to the correlation each time when we added these points? How did the correlation change each time? It decreased each time. Why? It's outside that linear pattern, yes. So those points that we were adding, those are outliers, something out of the pattern. They have large residuals. Go look at number 3. Which outliers had the greatest impact on the least squares regression line, the vertical or the horizontal outliers? The vertical outliers when it shifted my line up and down? Horizontal ones, what did that change? It changed everything. It changed my slope and it changed my y-intercept. So those horizontal outliers had the largest impact. had much more leverage on the least squares regression line. We call these, unsurprisingly, high leverage points. Because it changes our slope and it changes our y-intercept and it changes our correlation. We call something an influential point if it's a point that, if removed, substantially changes the slope, the y-intercept, or the correlation, our R value. So that is what an influential point. If I remove it, it substantially changes, I forgot my y, the slope, the y-intercept, or the correlation. All right, flip her over. Outliers would be anything that is out of the pattern, anything that has a large residual. High leverage points are going to be horizontally added things, things with very large or very small x values. It's influential if, when removed, there's a big change to the slope, the y-intercept, or R. Horizontal outliers are going to tilt our line. Vertical outliers are going to shift the line up or down. A good least squares regression line has a low standard deviation and a high R squared. And then just some notation over here for you. This is how you calculate different pieces. We can calculate the slope by taking our R value and multiplying it by the standard deviation of y over the standard deviation of x. The average of my y's is equal to my y-intercept plus my slope times the average of my x's. So I can work backwards. If I know what the mean of y and the mean of x is, and I know what the slope is, I can work backwards and find that y-intercept. I think we're going to start class tomorrow with going over the check your understanding. We're going to do that piece first. Then we're going to talk about one last piece that we need to cover. Test next week, I've had to bump that up to Thursday. It doesn't cut into anything about the amount of time that we have to do it. I was hoping that we could go and actually jump our Barbies off the balcony in the PPAC, but they told me there's rehearsals all next week in the PPAC, so I can't get us in there. I'm still going to try to find a time that we can go down and do that. It's just not going to be before the test. So we were going to spend a day down there doing that. We're not going to be able to do that before the test. So test is Thursday now. We still have the same amount of in-class time to work on and review those things. So tomorrow will be our last lesson. Monday, we're going to talk about your free response, and I'll give you guys the review. Also, before I forget, new homework. Due on Tuesday. Make sure you pick that up before you leave the room, guys.